Welcome to Unreal Gems. Finally, this is the last video in the Ragdoll physics asset creation. We are going to take a look at collisions, which are a key part of the process because you don't want extremities to go through each other, and also mirroring, because you want to save as much time as possible and you can mirror rigid bodies and constraints. Okay, so since we don't want to repeat the whole process again, we are selecting all the rigid bodies of the left arm and we are going to try to mirror them. So let's go ahead and right click and press mirror or M, and Unreal is going to try to mirror all of the rigid bodies and constraints, but as you can see it has several problems, so we will need to fix them by hand, although we don't have to create all the rigid bodies and constraints again, so that's something good. But it still has some issues when the skeletons are not standard. Okay, so let's position the rigid body properly for the clavicle, and now let's position the constraint. As you can see, it is rotated, so it is not going to work right away, so it's going to probably give us trouble just because of the position. So let's go ahead and first start with the hand, which is going to be simpler, and let's reposition the rigid body so it fits the hand properly. I'm rotating it a little bit and placing it properly, so just bear with me. Okay, so now the rigid body looks okay, so we need to see what's happening with the constraint. It also looks wrong, but first I'm going to place all of the rigid bodies, so let's go ahead and deal with the forearm. It's a matter of placing it properly again, so I'm just changing its location to better fit the forearm. It is already looking better, but still we need to do some fine tuning. Okay, now it is looking almost there, so let's go ahead and deal with the upper arm, which is the only thing left. Again, let's place it properly, rotate it if needed, and now all of the rigid bodies are looking a-okay, but we have problems with all of the constraints, which are going to be key, as you are going to see. We are going to test now the clavicle constraint, but as you are going to see, it is going to probably not work, so it is what it is. Okay, so let's select the rigid body, and you are going to be able to see when things are wrong, what happens, which is important. So, okay, let's go ahead, select it and simulate selected. As you can see, the arm pops even when there is no gravity. So you can see that probably the constraint is facing the wrong way. And when that happens, some things will pop when they don't need to pop. So I'm trying to rotate it, but still, since there are more issues, not only this constraint, it's still not going to work. So you are going to see that it is better to start from a lower rigid body, because if not, you don't know where the problem could be coming from. So you need to be sure about where the problem is and then attack the higher rigid bodies. So let's go ahead and simulate again with the changes, but as I mentioned before, this is not going to work. So I am trying to make it as close as possible to the right clavicle, but still you are going to see that it is not enough because other rigid bodies are causing problems. So it's still popping, as I mentioned before, so no surprises there. We are going to see if other constraints are giving trouble, but as I mentioned before, it's probably better to just deal with lower constraints instead of doing everything at once. Okay, so let's try to fix the elbow constraint, rotating it and making it aligned with the arm. Okay, so it is looking now better, but we are trying to make it the same as on the right arm. So let's go ahead and do it. Okay, so now it is looking perpendicular and it is really close to the left arm. So we are going to try to see if this works or not. But first, we still have the problem with the constraint of the hand. So let's go ahead and also rotate it and resize it. Okay, so right now it is almost there, but we need to rotate it a little bit more so it is mirroring the left hand. Right now it has the wrong orientation, so we need to fix that. Okay, so we are really close to the left hand, but still we are a ways off. So let's go ahead and do the final rotations. Okay, so right now we are looking really close, more than enough. So as you can see, we are almost there, but you're going to see that still we are having problems. So it is popping again, so no worries. What I said before, right now we need to test the hand first, see that everything is okay with that constraint, and then go up. So the hand is looking awesome. As you can see, full range of motion. So we know that that is okay. We now go to the forearm. Let's simulate and see what's happening. It's looking perfect. So we know that the problem is closer to the bicep or the clavicle. So right now we are pinpointing where the problem is. Let's go ahead and test the bicep. You can see here that it is popping. So we have a problem here. Maybe not the only one, but still a problem. Let's go ahead and test out a small solution, but I'm just repositioning the constraint location. That may be the cause, but let's see. Simulate, it is still popping. It's still trying to get away from the body. So that means that there is probably another issue. And if we simulate the arm, the clavicle, we are still having trouble. So let's go ahead and select the rigid body, and you can see when you are selecting it, the clavicle has no purple rigid bodies, but the bicep does. That means that we have collisions enabled, and that is going to be a problem because the bodies are going to try to repel each other when they can't because they are close together and one close to the other one. So this is what's causing the popping, and this is clearly a problem. When we disable the collision, it's not going to try to get away from the spine and things should be okay, but we still have problems with the constraint. So right now we are sure that the problem is in the constraint, so let's deal with that and fix the issue. For that, we are going to reset the child and parent transformations, and now let's position properly and rotate properly the constraint so it does not give us trouble. So I'm just doing the same process as always. Check my other videos if you want to know how to do this. And right now we are trying to mimic the left clavicle in the right one, and as you can see it is looking a lot closer, but still not there. Let's go ahead and take a look at both of them together. You can see that we switched the starting position of the other clavicle, but we will deal with that later. So let's now try to position it properly and get those limits working correctly. As you can see, we can switch with 1 or 2 to switch between the swing 1 motion and the swing 2 motion. We are trying to just dial it in. Let's go ahead and rotate it with this time Alt, so the starting position rotates without moving the limits, so we can better mimic the other clavicle, and that's going to be pretty much it. If we now test it, we should get a better result, and let's go ahead and do that. As you can see, it is not popping anymore like crazy. It still has some small movement, but because of what I mentioned in other videos, the planes are not aligned, so the simulation is trying to get them together from the starting point, which is outside of the range, so that's making that small pop. So we can activate both limits, so this doesn't happen, and right now we should see an almost perfect simulation. It's still popping a little bit, but I think it is good enough to have proper ragdolling without weird problems. So let's go ahead now and check how we can activate the collisions, because if we don't do them properly, the extremities are going to clip, and we don't want that, because some rigid bodies right now, if we simulate, everything is looking good, but they can go through each other, and we don't want that. So we need to deal with the collisions in order to avoid that. Let's go ahead and turn off the no gravity simulation and turn back on the floor collisions so we can see the ragdoll properly. It's looking great, to be honest. It's looking really good right now, but we can still make some adjustments. Like, for example, there is some jittering that we can fix with damping and some other things, but we are going to fine tune the simulation after, so don't worry about it. Okay, so let's test a little more the ragdoll. You can see that it is looking really, really good. Maybe some jittering, as I mentioned before, but everything else is looking dandy. So I'm really liking the result. As you can see, I'm doing really weird movements, so usually they will give us trouble. So as you can see, we are going to fine tune it a little bit more so we don't get those issues. So let's go ahead and turn up the damping on the head. So angular damping and linear damping, and also the hands. So there is less jittering, there is more damping, and the energy gets used up as the simulation goes on. So let's go ahead and 1 in linear damping in the other hand, and 5 on the angular damping. You can go higher if you want the simulation to have less jitter, but bear in mind that it will be less reactive. So just be careful. We need to be in a middle ground. As you can see, it's looking better than before, less jittering in general. And right now, I'm liking the results a lot. But we still need to deal with the collisions, because right now, as I mentioned before, rigid bodies can overlap each other, and we don't want that. We want them to have proper collisions with the other rigid bodies. Well, say goodbye, Citrine, and let's go ahead and do the collisions now. Okay, so let's start by selecting a rigid body. You can see that there are no collisions because the rigid bodies are white. So let's go ahead and select everything, and we are going to enable collisions for all of them. This is easier, I think, because now you are sure that you have a correct physics asset, and the only thing that can mess with everything are the collisions. So now we will disable collisions for contiguous bodies so they don't collide with each other and they don't create problems. Okay, so now you can see that the contiguous body is in white and the rest are in purple. So with this, let's do the same thing for the other leg. So disable collision for the ones that are closer together. And now with the thighs and the calf, same thing. Same thing for the other thigh and the other calf. And we would repeat this process for the whole body. We want to simulate quickly so we can see problems appear before doing too much. So that's why I'm simulating, and we will simulate selected to just see the things that we are working on. So let's go ahead and turn off gravity and floor collisions so we can see what's going on. You can see there that it is doing something weird. So as we have mentioned before, this means that there is a problem in terms of the pelvis this time, because it is colliding with the thigh and that's creating problems. So again, we need to disable collisions and everything is looking perfect. Let's go ahead and do the same thing for the other leg, because we are going to have exactly the same problem. So let's go ahead and select the thigh and the pelvis and disable collision. And now we can simulate from both legs down, so we can see if there are any problems. Okay, so everything is looking perfect. Nothing is moving without gravity. And now it would be a matter of repeating this step for the rest of the rigid bodies. And with that, we would be done with the character. I'm not gonna do it because I don't want the video to be too long and the process is exactly the same. Okay, so now the last thing that I want to review is that if we go and select all of the bodies and we change to kinematic instead of default or simulated, and we choose a preview animation like this one, the walk forward animation, you can see that every single rigid body will follow the bones of the skeleton, and right now nothing is being simulated. So if I now choose the hand and change the setting from kinematic to simulated, and of course simulate, you are going to see that the hand is going to follow the simulation, while the rest of the rigid bodies follow the bones. If I now change back to kinematic and simulate, you are going to see that the hand also follows the bones. If we want to see it more clearly, let's go ahead and select the forearm too, and let's switch both of them to simulated. Now you can see that both of them are being simulated while the rest follow the bones. Okay, so that's it. We are done with the Ragdoll physics asset. As you can see, it's a tedious process, but the result is worth it. So if you have found the video helpful, go ahead, like and subscribe, and we'll see each other in the next videos. Huge shout out and thanks to all my Patreons. As you know, making these videos takes a ton of time and effort because I research in depth all of the topics that I cover. So if you want me to keep making awesome stuff, consider supporting me on Patreon.